We have talked about the electronic configuration of atoms, and in all cases the atoms were neutral. However, sometimes may be useful to look at the electronic configuration of ions in which the number of electrons is not the same as the number of protons, because this will tell you a lot about the reactivity. Let me give you an example. In here we're being asked to write the electronic configuration of these ions. I will not do them all, but if you look at oxygen 2 negative, well, we know that the electronic configuration of oxygen is 1s2, 2s2, and if it were neutral, it would be 2p4. However, we have two extra electrons. So instead of 4 electrons in the p, we'll have 2 more. That is 2p6. This means that the whole level, it's a full shell. And if it's a full shell, it means that it's specially stable. This explains why oxygens will try to gain 2 electrons, because by doing so they will gain a full shell. You may also heard about the octet rule, which is specific only to the second row elements, but the principle behind the octet rule is gaining a full shell. The same can be said for potassium. Potassium has 1s2, 2s2, 2p6, then 3s2, 3p6, and now 4s1. However, if it's potassium plus, this is 0, and again you have a full shell. You can do the same for the other elements, and what you will see is that commonly there are some ions more common, more frequent than others, because they either achieve a half full shell. In the case of phosphorus 3 plus, you could do the same. You will see it's 1s2, 2s2, 2p6, 3s2. It's not the whole shell, but it's more stable. So you will see some common ions in some specific elements depending on the position on the periodic table, and that explains a lot of reactivity. For one day we'll be able to calculate something called the oxidation state, that is the charge of that specific element in a molecule, and you will see that for sulfur these charges are most common. If you do the electronic configuration of these ions, you will see why these charges are so common. It's because they either achieve half full shell or full shell, and that provides a lot of stability.